All right then. Let's try to solve question number 4. Basically, question number 4 is all about work, energy, and power. But now let us read the statement and see what does the question actually want from us. Now it says question number 4 for 7 marks. It says to us, a cyclist is freewheeling down a frictionless inclined plane at a speed of 8 meters per second as he passes point A, which 3 meters above the ground level, as shown in the diagram. The total mass of the cyclist and his bike is 80 kilograms. Okay, and now they say to us, calculate the speed of the cyclist at the bottom of the inclined plane at point B. Okay, so now this is what is happening. One of the most important things that you need to take into consideration, we are talking about the surface AB, and we are told that the surface AB in this case, it is frictionless. The moment they tell you that the surface AB, it is frictionless, what does that mean? That means there are no non-conservative forces that are acting on the surface. In this case, that means change that means mechanical energy at point A it is going to be the same as mechanical energy at point B due to the absence of non-conservative forces. That means in this case, the only force that will be acting on the cyclist, it will be weight, or we can say gravitational force. Now in that case, in order for us to calculate the speed of the cyclist at the bottom at the inclined plane, meaning remember, we were given the velocity that the cyclist was traveling with. He was traveling with initial velocity of 8 meters per second, meaning initial velocity at point A, it will be 8 meters per second. But now we are looking at the final velocity of the cyclist at the point B. Now this is what is going to happen. Okay, like I said, we're going to use to calculate this in final velocity, we are going to use conservation of mechanical energy. So we're going to say mechanical energy initial, which is at point A, it's supposed to be equals to the mechanical energy final at what? At the point B. Okay, so now what's the formula that we use to calculate the mechanical energy? We use gravitational we use yes, kinetic energy mvf squared at A plus gravitational potential energy at point A, which is going to be the same as kinetic energy at point B plus gravitational potential energy as well as point B. Now we're going to plug everything that we need. Now let's go back to our sketch or our diagram. So now we have 1 over 2 mass. What is the mass of the cyclist and his bike? Is 80 kilograms. We're just gonna substitute 80 kilograms over there, and therefore the initial velocity of the cyclist, which is at point A in this case, is equals to how much? It's 8 meters per second squared, plus now what is the mass of the cyclist and his bike is 80 kilograms, and then gravitational acceleration is 9,8, and then the height at position A in this case, we have gravitational potential energy in this case because the cyclist is above a certain height from the ground level. In this case, it's 3 meters, is equals to, now let's talk about the mechanical energy at point B. Now let's talk about the kinetic energy at point B. Now we're gonna have half multiplied by mass of the cyclist and his bike, which is 80 kilograms, and then the final velocity at point B. It is basically what we are looking for. So we're just gonna substitute that as velocity at point B squared plus the mass of the cyclist is 80 kilograms multiplied by gravitational acceleration, which is 9,8 meters per second, and then height at point A in this case above the ground level, it's 0. So that means here we're gonna substitute 0, and therefore what we do, we go to our calculator. Here we have 40. We're just gonna say 40 multiplied by 8 to the power of 2. In this case, how much do we get? So here we get 2,560, and therefore here we're going to say 80 multiplied by 9,8 multiplied by 3. How much do we get? we get positive 2352 is equals to, here we get 40 VB squared, and then there we're gonna get a 0. And therefore now let's just add the numbers. We have 2560 plus 2352. In this case we get 4,912 is equals to 40 over VB squared, and therefore we divide both sides by 40 because we are looking for velocity at the point B in this case, which is squared. Just going to say this divide by 40, and therefore how much do we get? We get 122,8, and therefore we get root of the squared on both sides. Therefore final velocity at the point B in this case will be equals to 11,082 meters per second. Okay, that's how we calculate it.